yesterday we looked at our L'Hopital's from two different equations. Today we're going to look at it from a table. So it says the table shown gives values of the twice differentiable functions f and g and their derivatives f prime and g prime with selected values at x. What is the limit as x goes to 0 of g of x squared divided by 3x plus f of x? So remind me, when we are finding a limit, what do we want to do first? Yeah, we want to try and see if we can directly substitute. So I have the limit as x goes to 2 g of x squared divided by 3x plus f of x. So if I plug 2 into x squared, what do we get? 4. If I plug 2 into 3x, what do I get? And then we're just plugging it into x, so we get a 2. We're okay with that. Yes, we'll move. And then, instead of plugging it into a function, we're just going to use our table. So what is g of 4?
4. Or 0.
0. What is f of 2?
4.
Negative 6.
What?
So I have a 0 on top, and then 6 plus a negative 6 is also going to give us 0. But remember, we talked about yesterday that if I get an indeterminate form, we don't want to use equal signs because you can't technically equal an indeterminate form. However, we also don't want to have to erase all of this, so I'm just going to put an X through it. Right? Because remember, your tests are going to be timed, and so as long as we've X'd out stuff that we no longer want to be graded, then we are okay. Now, I do have to indicate that we are an indeterminate form. So remember, we do that by looking at the limit of the top, which we did say is going to equal what? 0. As well as the limit from the bottom. Because if I look at them separately, which we're allowed to do, I can say that they each equal 0. It's only when we put it as 0 over 0 that we have incorrect form. But since we do have 0 over 0, what can we do? Yep. And what does that tell us that we need to do? Correct. So I'm still going to be taking my limit. So I haven't evaluated yet. So my limit symbol is still going to be there. But I do want to take each of the derivatives. So first off, what is the derivative of g of x squared? Not quite. Because the x squared is only inside. It's not g of x squared. So do I have stuff inside my function? So when we have stuff inside functions, what do we have to apply? The chain rule. Okay. So my outside function is just g. What's the derivative of g?
G prime.
G prime. Okay. So I have g prime of, I don't change my inside. Then I have to multiply by the derivative of the inside. So we are going to get a 2, but it's specifically going to be what?
2x.
2x. We're allocated with that. And again, this is the part that most of us forget. Okay? A lot of people will get the g prime of x squared, but because it's in function notation, for whatever reason, we forget the 2x part. Okay. Then, what's the derivative of 3x? 3. And what's the derivative of f? F prime. Alright, so again, we want to evaluate now, so we're going to direct substitute. So this time I get g prime of 4 times, well 2 times 2 gives us another 4 divided by 3 plus f prime of 2. And since our table does not give us a g double prime, we're really hoping that this works. because we don't want to have to take our loop field again because we don't have enough information to do it. So what is g prime of 4? 5. And then what is f prime of 2?
7.
7. Have I evaluated my limit now? So free response question, could I stop there? Yeah. Okay. Now, hopefully, we could do this. 5 times 4 gives us 20. Divided by 3 plus 7 gives us 10. So we get 2. There we go. Okay with that. Which is why sometimes it's better for us to stop while we're ahead. But, yes, no, maybe so.